So we will start out, actually we're going to transition into talking about specific web GIS implementations tonight, a little bit early. And more specifically, we will talk about using ESRI REST services. REST services are very important in the ArcGIS JavaScript API and ArcGIS Online. You can also do things with REST services without programming. There's REST pages in which we can query and get information from web GIS services, and we'll define how that goes. We're not going to get a full class ahead. We'll get some ways into the Wednesday lecture. Mostly tonight, I think we'll talk about defining what REST services are and how we can work with them. And we'll pick that up Wednesday, the 10th. So what is a REST? REST sounds like something I don't get enough of. But beyond that, REST also is an acronym. Stands for Representational State Transfer. REST is a way to communicate across a remote network, in this case between a client and a server. So in this case, a client on a mobile device or on a desktop device can make a request, we call a RESTful communication, to the server for information. And we'll start, as I said, talking about just using REST services plain. And we'll see later how we use REST services in ArcGIS Online and ArcGIS JavaScript. A client application uses the REST API to send a request to a map service. If the communication meets this protocol, which we'll talk about now, it's called, as I said on the previous slide, it's called a RESTful communication. That request may just be a request on a URL. The request of RESTful communication comes in the form of a URL. So the server gets this URL, interprets the REST request, and sends back a result. So more information about these RESTful communications. And the base, and we'll do these in a second. The base of a REST request is a web URL. The web URL is the URL where the map of the server where the map server resides. So out here on the internet, there is a server, a web server with a URL, and on it, someone has created a map server. So we make a request of that map server using a REST URL, and then the URL has an argument to it. And those arguments will specify exactly what is the thing that we're asking about. Why do we use RESTful communications? Consistency. I mean, like that's true with any communication. Request and response follow expected structure. Readability. The REST request is in plain text. It's a URL, so it's very easy to read the request and see exactly what's being asked for. And then efficiency. The REST request is compact and can take advantage of web caching. In this specific, and REST APIs, application programming interfaces, are certainly not restricted to ArcGIS Online or Server or ESRI, but that's what we're going to focus on since that's what we're doing in this class. ArcGIS Server sites, and we'll be talking about this in two ways. ArcGIS Online and ArcGIS Server publishes a list of available REST API services in what's called a REST endpoint. The REST endpoint is a website that, as I've listed here, explains all of the REST requests that are possible. The page is a list of all map and feature services that are available instead of what functionality has been exposed for each. And the URL is as follows. This is the server's URL slash, another typo, not good, it's one, there should be one slash ArcGIS slash rest slash services. So in two cases, let me here is Esri. One of Esri's URLs is at this, they have REST services on this web server, services.arcgisonline.com. And notice I put the three folders in that I just put on the slide, /arcgis/rest/services. So, wow, they're 10.2, not 10.3. So we'll see some of the different things we can do here. And beneath that, they have different folders with specific types of REST services. And if I scroll down, so this is a REST endpoint. And they have different specific services. For example, GEO world map. So beyond the services directory, we have some slides on this. Then you have the name of the map service, in their case GEO world map, and then /map server. So this describes this REST service that ESRI has made available. This map is designed to be used as a general reference map. The map name, and then there's some more details. We can see on the REST endpoint a legend. This one's not very exciting for that. It's just got one base map. And so this describes the tiles. We'll talk about that. The GEO web service is not features. There's no features that you can click on. It's a background base map. So a background base map is presented to us in these tiles with 17 zoom levels. So if I am getting a little ahead of myself, we can view in, we'll have slides on this, there's 5 different ways in which we can view a REST endpoint by default. If I click ArcGIS JavaScript, this brings up a map of the REST service. But this is a map service, there's no features. I don't click and get, like I don't click on China and it comes up and says China. It's just a background map. So that's level 0. So these are, there's no, these are, this, in other words, it's just an image. And there are 17 levels of images. And as you zoom in, all it does is load. Now that was level 0, this is level 1. That's how it's so look how fast that is. That's level 2, 3, 4, and it should go 17 times. 5, 6, 8. There may not be 17. 9. No, they only went to 9 at least. It may vary by country. So again, each one of these is tiles. As I zoom to this area, there are map tiles in the map service that are drawing. And the downside to the map tiles of a map service is that we can't get, none of these are GIS features I can click on. If I want to know the road, the name of the road between these two cities, I can't get it from this. It's just a picture. The advantage is look how fast, it's very fast, because it's just rendering images. So as you see here, this will come up very quickly. It says, if you're familiar with National Geographic wall maps, it's there. And I happen to like this service, and I'll use it on the background of a lot of my maps. It might zoom in more detail when we go to the United States. But it provides a National Geographic looking backdrop. Yeah, it does. It goes down. Maybe now we'll get the full 17. So you can go from a map of the world right down to the neighborhood. And Esri has, it must be billions of images, because for each of these 17 levels it has images for most, we saw not all of the world, but most of the world. So they have on their server billions of images that they retrieve based on where you zoom.
Which service do you need?
This was, the server is services.arcgsonline.com, and I went to Nat Geo World Map. As you see, there's many others.
Yeah, that's it.
Yep. Additionally, within these folders, they have more services. I can click on demographics, and they have maps. See, they don't have, maybe I'll bring up one of ours. They're all map services here. There's a thing called a feature service where you actually can bring up actual GIS data. So we have a service called USA Tapestry. Well, that looks interesting. So you can see the legend. Well, that's weird. And they've broken, I don't know how they arrived at this. They broke down every census tract in the United States to these 17 categories of people. I don't know how I feel about this. From high society to global roots, etc. It shows the dominant segment of person in every category. Okay. It's also tiled. And this is a map service. I have to look. As you zoom in, I'd like to see how they determine this. I don't remember the legend. Oh, here we go. When we zoom in, you see areas of Buffalo. This map service probably only applies to the United States. So the areas of purple they've called high society. What do I live in? Upscale avenues. They've never seen my house. But they might rate this a little differently. And then over here in Genesee County, factories and farms. It is a farming area. Yeah, again, I don't know about this. But it shows how you can get more specific data. Huh. I don't know. If we go to one of ours, a lot of these are proprietary. Let me see if I can. These are E&E's ArcGIS server services. So now instead of ArcGIS Online, these are services our company hosts for clients. I'm trying to think of what I can show. Hackensack. So here's what I'm talking about with feature and map services. I can't recall if I have a slide. Map server is like what we just looked at. It provides these tiles of images. With ArcGIS Server, you also can publish a service called Feature Server that lets you actually get at the GIS data and run. You can even do geoprocessing through REST and ArcGIS Server JavaScript. You can do just about anything you can do on the desktop now, including geoprocessing. And notice, tying all this together, if I click on the REST services, it gives me information about the REST service in JSON. That's a JSON formatted string. If I click on Hackensack Feature Server, it has 3 layers: photo points, toxic points, and NPL, priority sites. So there's a potential project with the EPA to study pollution along this river, which is in New Jersey. But these are additional REST operations that I can apply in the feature service. I can query, build an attribute query. I can apply. I can actually edit using the online interface. generate, render, and delete features. So those are all REST endpoints that let us do things. So you can edit through the REST endpoint, and ArcGIS Collector, which we'll learn, does that. So as they sail up, here's New York City. These are the yellow dots are potential sources of pollution. These green squares are our team. Yeah, they rode down the river in a boat last Thursday. These are points they took using Collector, using the software we'll do. They entered, an information, and they attached a photo. Collector uses the REST endpoint to add these things right to our data, which is right on our server. So you can even attach media. For example, there's the photo they took of that location on the river. Or there's what the river looked like there, and so on. And so on. So there's some examples both of ESRI's freely available REST endpoints and some of our REST endpoints for our projects. So here's a screenshot. I just showed you this, but a REST endpoint can have subfolders. There's how I showed you ESRI subfolders, and our company's example, we grouped a different subfolder for every client. And then here are the available REST services that we can do things with. And we saw some examples of doing that already. So when you click on a REST endpoint folder, say I clicked on demographics, demographics gets appended to the URL. We see folder demographics, it tells us the version. I'm surprised they're not 10.3. We can view them in an ArcGIS.com map, and this lists the services that are available within that folder. And supported interfaces indicates that ESRI has allowed us to make requests of these services using REST, which is what we're talking about this evening. So now, you click on, so we've gotten through a folder, and we click on one of these specific map services. You can see it's a map service, not a feature service. And let's say we clicked on ESRI service, USA average household size. So now those two items get appended to the URL. It says ArcGIS REST services demographics is the folder, USA average household size /map server. I don't know if you noticed, but on our site you saw that you can have both a feature server and a map server on the same map. So you need the map server on the end, even though this just says map server, to indicate that the map server is what we're looking at. So now it tells us we've gone to the map server. I showed you there's a couple different options. If you want to view the service right from here, you can do that. So notice we're taking advantage of the REST service endpoints already without even writing any code yet. I mean, we will learn to write code, to code in class, but you can do things without even programming. We see the service description. You can get the legend, and these are sub-layers available. And then the 17 tiles, just like the National Geographic, that are available. Questions? So in the REST endpoint page, there's 5 options. Not all 5 options may always be there for viewing the map service. So to start, we did this when we looked at the tapestry layer. We clicked on ArcGIS JavaScript. This is a simple viewer that the ESRI has available using the ArcGIS Server JavaScript API. They built this viewer using the same language that you'll learn how to do yourself later in this course. And I don't think I need to bring this up again. You saw me do that with the other layer. That brings up just a very simple viewer where you can zoom in and out and view the map service. You can also open up the map service in an ArcGIS Online map. I actually did that when I showed you this, the Hackensack survey. You can't see it yet. There it is. So that's in our, so going back to my tapestry, if I say show it in an ArcGIS.com map, it'll come up with this ArcGIS Online map with the data loaded. Nice thing here is you can click here and get a legend. We will do more every Wednesday next week in ArcGIS Online in the course too. So now we can view the service using ArcGIS Online, or as they call it, an ArcGIS.com map. That was that second option. More and more the trend is notice all the functionality without coding. I mean, learning these programming languages open a lot of doors for you to develop a lot of very custom specific tools, but more and more there are things that you can do just by configuring sites and opening up sites without writing a line of code. That New Jersey collector site we set up in 15 minutes. And you'll see when we do the lab, that would have taken me half a year of coding 10 years ago. Times have changed. You'll see when we do that lab how easy it is to set up one of those sites without one line of code. I'm not trying to discourage anyone, but it is a different world. We also have very complicated sites we've done for the Army and other clients that could never be done with something like this. You can also download a KML file of the service, which can be viewed in Google Earth. To see when I clicked on that in the REST endpoint, it opened this KMZ file. If I click on that, it should, yep. That's interesting. That's never happened before. Try that again. I'm curious. Google Earth on these things? Work there. I don't know what's... This is something wrong with my laptop, not... I'm able on the UB machine to get to Google Earth. And I brought up CNN, I still have an internet connection, so that's kind of strange. Well, we can see in this, it's not that big of a deal. There's something weird with my laptop. But you know Google Earth, you know what it would look like. It would come up and show the layer on Google Earth. So nice thing about that, and that's becoming another thing I've dealt with. It is a good thing, but it's a challenge over the years, is we have a lot more geography, GIS savvy people than we used to have. When I first started, we'd go into like behind the black curtain, come out with these maps, and everyone was amazed. Now more and more people can do those things, light GIS skill on their own. You know, they know how to use Google Map or Google Earth. So these types of people are very happy when I build these services, because they can just load the data into, save it as KML, load it in Google Earth, because they already know how to use Google Earth. These people, Gene, who worked on that project, doesn't know a thing about ArcGIS, but he's used Google Earth. So I can set them up so we can load those points from the river right into Google Earth and work with it. That's another trend that I'm noticing, which is good. You can also load it right into, here's another new and interesting trend. Let's see if this works. You click ArcMap, it will download a layer file. And you can actually, I'm not too optimistic. I'm at 10.3, it's about, you're at 10.2, it's about the same. We'll give this just a minute. You can load the layer into ArcGIS, into ArcMap. That's interesting too. I think there's something weird going on. So now this layer will show up as a layer in ArcMap, even though the source is not on your M drive or your C drive, but the source is the internet, and the source is ESRI's REST endpoint. It's not too slow considering. I remember today to disconnect my work network drives, and that speeds things up. Yeah, it's not. Something's not working. Something's up. This is going to get rebooted when we're done. But you can see it in the slides. I've loaded the tapestry layer, the household size layer, right into ArcMap through a layer file. From the REST page, we can also get to descriptions of individual layers based on their feature position. And so we have, we're building this URL, REST services demographics. This one happens to be 2010 population change in the US map server. And you can get to the fourth layer through an index. It starts at 0. You have to be tricky because some of these are group layers in ArcMap. So here we have a group layer called average household size that has 4 layers in it. If you notice how that works, these layers turn on and off depending on the scale, the map scale. A lot of the ESRI REST services behave that way. So for example, if I go back to that 2010 population change, view it in ArcGIS JavaScript, see, at that point we're seeing, I'm going to view it in ArcGIS Online. We're seeing data at the state level. And see how the rest are grayed out. So these 4 layers work in tandem at this particular map scale. Even though the 4 layers are available, we only get states. So we see population change. Interesting that only Michigan is negative. I would have thought New York State would be. So as I zoom in, we're still up. So it's switched, see, to counties at this map scale. So now we can see counties drawn, and you can get a clearer picture within the state specifically which counties are low. And not surprisingly, a lot of rural counties are losing populations. Urban centers are growing, with some exception. Like Chicago's losing, and no surprise there, we're losing, unfortunately. this is the whole decade, so it doesn't take into account areas like Nevada and California that haven't been doing as well lately and are probably losing now. But the point more is the map layers. As I zoom in, it still shows counties, which was layer 2. Now it switched to tracts. So we can see specifically which census tracts are gaining and which are losing. And then the final layer, as I zoom in closer, no, not yet. Still not yet. Now it switched to block groups. And we can actually see which specific block groups are gaining and losing. So if that, why am I showing you this? To show you how you can get to those individual layers. And this happens to be set up where they switch on and off based on map scales. That's not always the case. You might have a map where they're all displayed. I have our collective map where there's 45 layers on it. They all could be turned on. They've got soil and water, ponds and streams. So to get information about a specific layer, you can click that hyperlink, and then you'll see, as the slide shows it, when I'll click counties, you'll see a 3. So now this REST endpoint goes right to layer 3 in the map server, and it describes the population group county layer. What fields are in it and so on. And here's the slide that shows a similar thing. It shows the map, a basic set of information about, more specifically, that ID3 counties layer. So we see the service description, Esri's description of that layer. You can see geometry type, it's a polygon, a lot of this information we can query using JSON. Shows the scales at which it's drawn, it supports advanced queries, a bunch of other things in there. And then, since it's a map service, it shows the 14 levels of detail, those tiles that we're talking about. It also shows us in here the renderers, shows what colors are used. And this is somewhat based on ARC objects. Those that were here in spring, remember the SFS symbols that were for Lab 3?
And those are the colors.
Those are the colors, yeah. And you see this is the RGB color. So we used, those that were here in spring used ARC objects in some very similar objects to program those colors changing on the desktop level. Now you can see the same ARC objects using an ArcGIS REST endpoint. And it also contains information about specific fields. So it lists in the data behind it, it lists the fields in there, lists the type of field, and again you'll recognize that enumeration from ARC objects. Whether it's an integer field, double field, string field, or so on. And we'll start. I think we'll end pretty soon, but we'll start talking about this a little now and continue on Wednesday. It also shows what operations are available on this layer. I can query the layer, I can generate a render or a legend, and I can return updates on the layer. So sometimes when you're investigating a new REST endpoint, that can be pretty useful because it tells you what things you can do on the layer and what things you can't. And that would be set up by whoever published this map. So when Esri published this map, they enabled the ability to do those things, but there's other things that they didn't enable the ability of. you can access a legend in the REST endpoint. I did this actually a moment ago. So through this legend link, oh, this is actually on the map service. What does this do? Not much. Population change. But most of them will have this legend link, and it will just, you may recognize these colors from the map we were looking at, but it brings up a legend for us of the 4 layers all together and what colors were used. These colors look better if you're playing along. You see they look better on the monitor than they do on the projector. As I mentioned here on NetGeo, here are some supported operations. Supported operations list the available requests for the service. And clicking the appropriate hyperlink on the page reveals more details about the request. So if we go back to NetGeo, we'll get a little bit into this and then we'll break for tonight. We're kind of ahead anyway. The export map operation. Now this is an operation or a method you can issue on the REST service. So we're taking a step forward. Instead of just getting information about it, we're now using REST to ask the map service to do something for us. So in this case, you can ask the REST service to export you a map in an image format. Oh, we are getting ahead of ourselves. And each one of these REST services has an API. And the API describes for us what we can do. So if I go to NetGeo and API reference, it tells us how to issue, for example, these are the different parameters, export map. So the URL, we'll see this more next week. The map services URL, we've been looking at that, /export. Remember we said all the request is all in the URL, is a way to export the map. You'll be doing this in Lab 2.
So this is describing how to export the map?
Yes. So here, exactly. If I go down to the end of the NetGeo map server, click Export Map, it brings up a little box here. It says Map Server Export. And then there's arguments. The arguments start with a question mark. We'll talk about this. So now, like I said, everything's on the URL. So if you think about, with this export operation, there's things we can define. A bounding box, a map projection, what image format do we want, JPEG or GIF, and so on. And so and this screenshot shows how we can define all those things. I think we'll talk about this and stop it. Just like last week, I don't want to start a heavy thing so late, so we'll stop in just a minute. It's almost 9:20 anyway, and we'll start this fresh at this beginning of Wednesday. But there's 2 different ways you can send a request to a server via REST: GET and POST. We'll talk about the differences, and then stop. Usually we use a GET operation. So the GET operation retrieves is a way of making a request to a server. And like it says here, it's the service URL to the REST service endpoint /export, question mark, and then the specific parameters that define what we want. What map do we want? Where do we want it zoomed in, et cetera, et cetera. What image format? So which operation has been requested, as well as the parameters, are part of the web service. And you saw that when I brought up the map. See these, after export these items over here, that's the parameters. They're right in the URL. So an advantage, once the screen pops up, you'll see I've written that. Advantages of GET, easy to read. It's right in the URL. It actually lets you bookmark. Because it's a URL, your browser can actually let you bookmark the request because it's a URL, and you can just bring it back using a Chrome or Firefox bookmark. When can we not use GET? Can't use GET with long requests. A web URL cannot exceed 1,024 characters. So if you have a real complicated REST request where that URL string is going to get that big, GET will not work.
Does that mean like you got more layers than you should?
Yeah.
Or you're just trying to pack everything in one layer?
Exactly. Remember, exactly. Every time notice that URL is getting longer and longer. That URL gets to be more than 1,000 characters, we can't use GET. And we'll talk about post next week now. Plus, another thing, and our company does this, because of security limitations, requests that modify information. So now we're just retrieving a map, so GET is okay. If my REST request changes the data, like that collector application floating down the river, that REST request changes the data because they're adding a point to the GIS database. They didn't use GET, they used POST. It wouldn't be good if someone could change your server just by typing in a web URL in it. That wouldn't be too secure. So the other limitation is GET cannot be used if the REST request would make a modification to your server. GET is read-only. And in that case, we use POST. With POST, the parameters are not in the URL. It sends a request via a form action. We talked about forms, I think the first night or second night. So notice there's no requests on the server. The requests are stored in the form. The URL just says query. There's no attaching. So when I click to use POST, it's still going to work. We'll do this next week, but notice the arguments are gone from the URL. It just says export. So because of that, POST is more secure. And then we will talk about the response and then leave, I promise. Responses can vary widely depending on what's desired. A response could be an image, it could be text, it could be HTML, and there's a bunch of different options like JSON, images, or a layer file. When you're issuing a request, and we're sort of assuming what's pictured here is a GET because you can see the arguments right in the URL, the format is specified with the F parameter. So this export GET request B box, we'll see this Wednesday, is the bounding box, latitude, longitude. And then F equals HTML means that the user is asking for the result to be delivered in an HTML format. In this example, F equals, I wish you could see it on here, F equals JSON. The result of the GET request is returned in a JSON format, like we learned about earlier. So the case study will be more involved. We'll pick up with this case study of issuing an export map on Wednesday, and you will use that in Lab 2. You'll write a JavaScript, an HTML page with JavaScript in Lab 2 that actually uses a REST request to export a map and return it to your page as an image. But we'll stop for today.
just